Hi there, and welcome back to math class. We are beginning the second workbook, so the first couple of units in this book will be focusing on algebra, and this lesson is very much a vocabulary lesson. We're going to learn the language of algebra. So you will need 8 of your flashcards, and also the piece that looks like this from your memory kit. Now I've colored mine just because I like the colors, but you don't have to do that. The important thing is that you have this piece ready to go. And I showed you in the assembly video how to prepare this piece, so it should be ready for you to use. Okay, let's start with our flashcards. Actually, let's start with giving this page a title. That's very important so that you can go back and find the notes that you need. This one is called Writing Algebraic Expressions. I'm using the title from your TABE books lesson so you can match these up with the lesson you're supposed to do. This will be practice 24 in the TABE book. So writing algebraic expressions is the skill that we're learning to do. Now, before you can write algebraic expressions, you have to understand what an algebraic expression is, and that's where knowing the vocabulary comes into play. So I'm going to give you definitions of these flashcards. And then on that other piece that you've prepared, we will put examples of each of these. So let's first start with the flashcards. I want to start with the term constant. So if you find this one, constant, and on the back side, I can't turn mine over, so I'm just going to erase the word, but you just turn your flashcard over, and here's the definition of a constant. A constant in math is a number or symbol that stands for a fixed value. And I think I'm just going to go ahead and turn on over to the other page, and let's do an example or two of a constant. A constant is a number or symbol that stands for a fixed value. And what does fixed mean? Fixed means that it does not change. So anytime I see that number or symbol, it is worth the same amount. So let's look at an example or two. If you turn over to this piece, and you need to lift up the constant door. So you're going to write underneath constant. And I can't lift my doors up, so I'm just going to put the examples off to the sides of these. Let me make this just a little bit bigger. Your doors raise up because you cut them the way they should be. Constants. Here are some examples of a constant. The number 5. It doesn't matter where I see that symbol. I know that that is the same value. It is constant. It's a number by itself. Here's another one, 8.1. That is a number by itself. It is a constant value. Sometimes numbers or constants are symbols, like the Greek letter pi. I use pi in geometry when I'm working with circles, and pi is always constantly equal to 22 over 7. That's the fraction. or approximately 3.14. And when we get into geometry, we'll talk more about where that comes from. But pi is a mathematical constant. Anywhere you see that symbol in a math book, it means 3.14. It's constantly the same. So constants are really the things that you and I are familiar with. It's the things that we've worked with all our lives as math students. To me, constant is the easiest term on this grid. Okay, so let's look at sort of the opposite of constant. The opposite of something that never changes is something that changes, and that is a variable. That's what the word variable means, changing. If you hear the weatherman say that the clouds are variable, it means that sometimes the clouds are really dark and sometimes there are no clouds. It changes. It's variable. So the definition of a mathematical variable is pretty similar. It's a letter used to represent an unknown or changing value. Most students, when I first meet them and I say, "What do you know about algebra?" they say that's all those letters. And they're right. Letters are a big part of algebra. But these letters are not just random. They're values. A letter is a placeholder. It's holding the place for an unknown amount that we have to find. So let me show you that on the examples. And I have written some notes I need to just look at. Okay, let's look at the variable door. Just open that up and let me show you some things about variables. Let's start with this one. I want you to draw a box. Plus 6 equals 10. So this is an unknown amount. They're not telling me what goes in the box. I have to figure it out. So I can use my fingers to figure this out. If I look at all 10 fingers and I take 6 of them away, that leaves me with 4. So the unknown amount we have found to be 4. We could also write that equation using a variable. We could say some number plus 6 is 10. So in this case, the unknown is written with a letter. Doesn't matter if I use a box or a letter. The unknown is n. And I know that n has to be 4 for this equation to be true. So that's just another way of writing that unknown. Let's look at another one. Let's suppose that I give you this equation. Some unknown number minus 3 equals 7. So we have to figure out what that unknown amount is. Again, if I look at my fingers and I have 7 fingers plus 3 more fingers, that would give me 10. 10 fingers take away 3 is 7. The unknown in this case is a 10. I could write that with an x. X minus 3 is 7. So the unknown amount minus 3 is 7. So x would have to be 10. It doesn't matter whether I use the box or the variable. It has to be 10 because that is what will make this statement true. Here's one more. Let's do it this way. 10 divided by something, try that again, something is 2. So look at your 10 fingers, put them in groups of 2, and so how many groups do you have? You have 5. 10 divided by 5 is 2. That is the unknown. What if I said 10 divided by x is 2? Well, in this case, x would have to be 5. We know that's true. But what I want you to notice is this. In this particular example, x was worth 10. In this particular example, x is worth 5. So x varies. It changes depending on the problem. And that's why it's called a variable. I had a student once who was absolutely terrified of algebra. And I finally had to just sit down and talk to him. I was trying to figure out what is scaring him so much. And he thought that every letter in the alphabet went with certain numbers, and that he was going to have to memorize all the letters and all the numbers that went together. And that is not at all what we're doing. We're just using the letter to hold the place, but we're going to use math to figure out the value of the letter. So don't be afraid of algebra. If you've had a bad experience with algebra, it's going to be okay. We can get you through it anyway. So just bear with me. Remember, you can always call your teacher if you need help with something. So here is the variable door. I'm going to section these off. I wish I could write under my doors like you're doing, but it's just not going to happen on here. So, okay, let's look at the next term. And let me see which one I want to do. Let's go ahead and do equation. Let's learn what an equation is, because the examples I've shown you so far are all equations. An equation is a number sentence, or a math sentence if you prefer that term. A number sentence with 2 equal sides. And an equation must always, without exception, has an equal sign. If you're not seeing an equal sign, you're not seeing an equation. So an equal sign shows me that I'm dealing with an equation. And let me give you some examples. Let me look at my notes here. Here is an example of an equation. I'm going to block this off. This is an example, so open your equation door. We have 6 plus 5 plus 2 equals, there's the equal sign, 13. Now, what that's telling me is that the left side of this math sentence, this side, which happens to have 3 terms, is equal to this one term on the other side. So if I add up 6 and 5, I get 11, plus 2 more is 13. So 13 equals 13. That is called a balanced equation. If the two sides were not equal, we would not have an equation, and we would say that it is not a balanced equation. But this one is a balanced equation because the left side is the same value as the right side. Okay, if it's not an equation, if it doesn't balance or if it doesn't have an equal sign, it's called an expression. So let's take this term, expression. First of all, I want you to know that expressions do not or does not have an equal sign. That's very important that you are able to tell me if we're looking at an expression or an equation. And that's the easiest way to tell me. Does it have an equal sign? If it doesn't, it's not an equation. Okay, so we have an expression is a math sentence or a number sentence. You can use those interchangeably with one or more terms. And let me give you an example or two of an expression. And then we're going to define that word terms next. Oh, one other thing about expressions. They can't be solved. You don't solve an expression. You simplify an expression. So if I ask you on the test, true, false, an expression can be solved, you are going to tell me false. An expression can be simplified. And let me show you an example of that. So let's look at this one right here. Let me mark off another section for expression. You open your door up and right under there. Here's an example, and this is an algebraic expression, so don't panic on me here. We're just going to walk through this. So I have 3a's plus 5a's plus 2 plus 6 plus 8a's plus 8. And you notice that it does not have an equal sign. It is an expression with how many terms? Let's count them. Don't do this. I'm going to erase these highlight marks, but let's count them. Here's 1, 2, 3, 4, 5, 6 terms. So I would call this an expression with 6 terms. And then I'm going to show you how to simplify this expression. How do we make this expression a lot shorter and a lot easier to work with? Well, the first thing I'm going to do is look for terms that are alike. And I'm going to look for all these a terms. There's an a term. There's an a term. And here that's a plus sign. There's an a term. So all of my a terms are marked. And I'm going to assume in this expression that those a's stand for apples. So if I have 3 apples plus 5 apples plus 8 apples, how many apples do I have? 3 plus 5 is 8, plus 8 more is 16. So I have 16 apples in total. Now I see 3 constant terms. I have a 2, a 6, and an 8, and all of those are being added up. So let's add them up. 2 plus 6 is 8, plus 8 more is 16. So I have 16 of those constant terms. So I combine my variables, I combine my constants, and I get a simplified expression. That's what this one is. I can't solve it because I can't go ahead and combine those last two terms. They don't match. One has a variable and one has a constant. So simplified expression has two terms. If that's an equation, we can solve it. If it's an expression, we can only simplify it. And you already learned a very important piece of algebra right there. Combining like terms. That's a huge deal as we work through these algebra course materials. Okay, we've done half of our pieces. Let's go to the word term next. Term is another. All of these are important. If they weren't, they wouldn't be on here. So here is the definition of a term. Let's do the definition first. Term is an element. I want to put slash piece of an expression or an equation separated by plus and minus signs. Remember, plus looks like that. Minus looks like this. Okay, so let's look at some examples of terms. Here's one. 3x plus 7 minus a. First of all, is that an expression or an equation? It's an expression because it does not have an equal sign. Here is one term. This term is saying 3 times x. So this is one term. Here is a constant term. It's a constant 7. And then out here is an a term. This is an unknown, which means it's variable. We don't know what a is. It could be 1, it could be 1,000,000. I have no idea. This term is also variable, the 3x, because we don't know the value of x. So we have two variable terms and one constant term. Here's the plus sign. Remember, terms have to be separated by pluses and minuses, and there's a minus sign. So this expression, let's write that. This is an expression with 3 separate terms. 3 terms. It's not an equation. It is an expression with 3 terms. It cannot be simplified. You always want to ask yourself that with an expression. Can I simplify it? Because in this case, the A and the X are not the same letter. Remember, in our other examples, we had all those apples that we were able to combine. In this case, we have X-rays and apples, and you can't mix those. Those are not the same thing. So this cannot be simplified. Okay, I know this is getting a little more complicated. We're getting out of the areas where we are familiar. We're familiar with constants, even though we didn't call them constants. I've been working with 7 since I was in kindergarten. I didn't know it was called a constant because I didn't need to at that time. But we're getting into areas now that are unfamiliar. So just hang with me. It will be okay. All right, let's go ahead and tackle coefficient. That's a big old scary word, but it's really naming something quite simple compared to other things. So let's look at this term, coefficient. Coefficient. Coefficient is a number multiplied by a variable. And I am going to use an example on this one because that's the easiest way to explain this to you. Let's take that term 3x that we just looked at. The x is the variable. It's the letter. The coefficient is the 3. It's the number that's stuck to the letter. This is saying 3 times x. The 3 is the coefficient. So a coefficient will always be attached to a letter, to a variable. So here are some examples. Let's go over to this one. Let me give you an expression here. We have 3m plus 6a. So I have the m and the a, those are variables. The 3 is the coefficient of m. And you guessed it, the 6 is the coefficient of a. So we have to call this number something. We can't just call it the number because that doesn't tell me a lot. Is it the 3 or the 6 if I say the number? So we call that number the coefficient. The 3 is the coefficient of m and the 6 is the coefficient of a. I do want you to know that coefficients can be fractions. 1/2 L. There's the coefficient. They can be decimals. Seven hundredths Z. So 7/100 is the coefficient. And I want to show you this one. I actually want you to think through this one with me. What if I have a letter that's all by itself? What is the coefficient of x? You don't see one, but there's one there. I call it the ghost one because 1 times x is the same as x. So if you have a letter by itself, a variable alone, you don't see the coefficient, but it's there. It's a 1. So you can put it in there if you need to. That's perfectly fine. And you will hear me talk a lot about the ghost one as we move through these lessons. Okay, we're almost there. We've got 2 more terms to do, and I want to start with solution. A solution, remember, only equations can be solved. The solution is the value, and sometimes solution, there can be more than one solution. But for now, I'm just going to say the value that makes an equation true. A solution needs a variable equaling a constant. Okay, so a solution in standard form is going to always put the variable first. And you'll see me talk about that too. Standard form is to always put the variable first. So let's put an example on here. We're dealing with an equation, so let me set one up for you. Something plus 3 equals 5. This is an equation. It has an equal sign. So what must go in that box to make this true? Well, 5 is what I'm aiming for. I have 3, so here's 4, 5. I need 2. 2 plus 3 is 5. So in equation form, that would say some unknown amount plus 3 is 5. X must be 2. That is the only thing in the world that will make it true. Now I could say 2 is the X. That's perfectly true. It is perfectly legal in math. This is just not standardized. It's not in standard form. Standard form puts your variable first. Most college professors, if you're planning to go on to college, they want the answer in standard form. So that's why we have to learn how to standardize our answers. But either of those is the solution. You can say it this way in standard form, or you can say it this way, which is not standardized. But in a solution, you have to have one variable and one constant. Actually, that's not true. Some equations have more than one solution, but for the ones we're looking at right now, it's one variable and one constant. So let me show you some examples of solution, or at least one example. I can't remember how I set this up, so here we go. I just did another example. Let me get my pen to work here. So something, okay, this is my pen is behaving strangely here. It should snap to. There we go. Something plus 6 is 10. So what is the unknown? What is the value that fits in that box? So I'll say, okay, we'll let it be x. Something plus 6 is 10. X has to be 4. Or 4 is x. Those are your solutions. Here's another one. Let's do something minus 5 is 15. So what would A have to be so that I could take away 5 and be left with 15? A is 20 or 20 is A. You can write it either way. So the solution, I'm going to always go with standardized. So the solution I'm looking for is highlighted there for those equations. Okay, one more, and that is the term inequality. Inequality means there's no equality. They're not equal. And that's exactly what I want you to keep in mind. Not equal. It's not an equation because it's not equal. An inequality is a number sentence or a math sentence in which one side is greater than, and that symbol looks like this, or less than the other side. And let me show you an example right here. If I tried to tell you that 5 equals 4, hopefully you would say, no, that's not true. 5 does not equal 4. 5 is actually greater than 4. It's not an equation. 5 is bigger than 4. So this is the inequality. 5 is greater than 4. So this is where those greater than, less than symbols come in. We'll be using those. So here's an example. I want you to think about this example before I talk about it. So open up that inequality door and let's put this example in there. Some unknown amount is greater than 12. So the unknown, the x, is greater than 12. So what could x be? Could it be 12? 12 is bigger than 12. No. Could it be 11? 11 is greater than 12. No. X could be anything 13 or higher. Anything more than 12. It could be 13, it could be 14, it could be 20, it could be 200, it could be 2 million, it could be 2 trillion, as long as it's bigger than 12. So the solution to this inequality is a little bit different. We don't say that the solution equals something. We say that the solution x is more than 12. We actually had the solution right there. It's anything bigger than 12. Sometimes these solutions are graphed. So they'll give you a number line and they'll put 12 on there. Let's put a few more. Here's 10, 11, 12, 13, 14, 15, 16, 17. And the arrows tell me that this keeps going on and on. So it can be anything above 12. It could be anything, even 12.1 it could be. So we don't want it to be 12, but we can go anything above that 12. So sometimes these are graphed solutions, and we'll be doing a lot of these too. So you'll learn how to do that once we get there. I just want you to realize that sometimes the solution to an inequality will be on a graph instead of on in standard form. But this is the standard solution. It's standardized. And then this is the graph solution. Let me just put the standardized solution. And then the graph solution. And either is correct. Usually when I was in college, I had to do both. I had to give the standardized form and the graph form. If you are feeling a little overwhelmed right now, that is perfectly normal. We have done a lot of flashcards. We've done a lot of information here. So here's what you need to do. I know you're overwhelmed, and it's going to be okay. Just because you're overwhelmed now doesn't mean you're going to stay that way. You need to learn these definitions because I'm going to be using these terms over and over. And if I'm talking about a coefficient, you need to know eventually what I'm talking about. So your job at this point, there is no test on this. I want you to study these flashcards. Okay? We are going to be doing a workbook page that will help you learn the definitions. So that's coming. But for right now, before you even do the workbook page, I want you to spend some time practicing with these terms. Practice with these flip doors. Raise the door and really study what's under there. If you need to, contact your instructor and he or she can help you with these. But we will be using them all through the next two lessons or two units in our workbooks. So you will be hearing me talking about these a lot. I hope you have a really good day, and I'll see you soon. Bye-bye.